Hello, my name is Aren Dawson, and this is my Anatomy and Physiology presentation. So, my topic was from November 2020 to May 2021 in Rome, Italy. There was a study done on 28 pregnant women who were, at the time, infected with the SARS-CoV-2 infection, aka COVID-19, in which they tested these women's maternal and neonatal systemic immune responses for spikes in very specific immune antibodies in their serum and breast milk, as well as the infant's saliva, 2 days after birth and 2 months later at a checkup. And to reassure everybody, it's extremely rare for an infant to get the virus from their mother via breastfeeding or close contact, actually, even so. It's encouraged. This was all more related to which antibodies became present due to the virus and how the mother's immune system helped the infant. This is all very important because it gives us an idea on if infants born from a mother that's infected with the virus, if they'll be safe or if they already have the antibodies to protect themselves. So their hypothesis was that they believed there was a correlation between the mother's infection with COVID and the immune response in offspring within the first 2 months of life. They thought that with and without breastfeeding, they would find an increase in the general and the spike-specific antibodies within the infants, thus proving that the mother's infection helped prepare the child's own immune system by passing down the antibodies via the placental transfusion or even through contact after birth. To set the experiment up, upon giving birth, the infected mothers were separated from their children immediately to prevent infection, just in case. So they were kept this way for the duration of their stay. The testing for the virus and the antibodies present in both the mother's breast milk and the infant's saliva and serum were done using very specific direct and indirect ELISAs, which test for specific enzymes using a multitude of different things. They collected samples 48 hours after delivery and 2 months later at a checkup. They collected the breast milk samples from the mothers who were breastfeeding. Only at the time when they decided to take the samples, at the 48-hour mark, it was only 7, and for the 2-month checkup, it was only 11 out of the 22. So they didn't get a huge base collection, but they collected saliva samples from both babies who were and were not being breastfed by the mother to see if that also maybe had an effect on the antibody buildup. So during both periods of testing that I've discussed, they performed the same tests and collections on everybody. They mainly used ELISAs. Like I said, I discussed that earlier, along with very specific materials in each that tested for the different things they were looking for. The materials they use helps them narrow down the search for the very specific thing. Essentially, depending on what they were looking for, they used a direct or indirect. A direct looks for antibodies, while an indirect looks for antigens. It gets very technical about what the ingredients were, and it's just a lot. I didn't want to get too deep into it. But the breast milk samples were diluted 1 to 100, and the infant saliva and serum were diluted 1 to 10 before being put in the respective 96 case testing chambers. It's a lot to test at once and just gives them better data. They would test for specifically IgA and IgG antibodies specific to the COVID virus, and also the total number of those antibodies present, so the general and the spike specific, as well as testing for the antigens from the virus to see if they were present in the infant's tests. So on to the findings. Now, of the 28 pregnant mothers, 7 of these babies were not seen again for a checkup, but 2 of the mothers had twins, so 21 mothers, 22 babies were tested, and from it all, they found that only 1 of these infants showed signs of vertical transmission, aka placental transfer, and had the antibodies against the virus in a small uptick. This baby was also one of the ones breastfed, but they know this is because it was the only baby to test positive for the virus's antigens after birth, while the others did not. So this baby had the virus, and that was through placental contact. It had it as it was born, which is very rare in this situation. They saw that IgA mostly had spikes after the birth but tapered off over time. And IgG mostly stayed the same no matter what time took place. With all this said, they concluded that maybe it was just time-based and they didn't have enough time, that 2 months wasn't long enough, but there was no real correlation, and I kind of have to agree with that. So this graph here was based on the measurements taken from the breast milk. So we see in the mothers that IgA, the total amount in the top left, was pretty normal after birth, and it fluctuated a lot at the 2-month mark. To the right of that, we have the total IgG, and it fluctuated a lot at the 48-hour mark, and it kind of condenses a bit in the 2-month mark. Not a lot of variation. The spike-specific IgA in the bottom left, we see a lot of variation in the 48-hour mark, and the 2 months later, it condenses and it just gets a lot more, no more variation, just kind of a general, almost zero number. And with the spike-specific IgG, as you can see, even in the 48-hour mark and the 2-month mark, it just flat lines, and there's hardly any difference at all. In terms of limitations, they only had a very limited number of women to test on because it was limited to the region they were in and limited to a specific hospital and women who had COVID at the time of giving birth. And there was only one child that showed signs of the maternal antibodies, and it kind of shows there wasn't enough time for the antibodies to transfer during the study, so time and participants were one of the biggest constraints. So how does this help us? This experiment gives us a better understanding of the specific virus, COVID, and how the antibodies created from it don't necessarily always pass down from mother to infant. And we know that while it does increase some antibodies in response, it does not protect the child from contracting it later in life or even during birth, because we saw that one of the children did get it. It helps us because now we understand something like this a little better and can develop more tools to help these mothers and infants. It's also important to note that during the time that this experiment took place, they needed to know as much information about COVID as they could, because this was during the height of the pandemic. Here is my works cited, and this has been my presentation. I hope you all have a good day.